Hello, this is Jared again with Uncontained Curiosity, and I'm going to be showing you how to 3D print your own bridge for your cello. And before we get into this, I definitely want to say that a good setup can make and break a cello. Even if it's a really cheap one or a very expensive one, always go to your local luthier for a quality setup on your cello. If this is something you don't see yourself doing in the immediate future, at least have a really good setup. And support your local luthiers. So to get right into it, here's one of the 3D printed bridges for my steel cello. This is like a first iteration before I had a better idea of what I was going to be doing. Before I go into actually showing you how to make this and model it, as well as taking all the measurements that you're going to have to get, there's two main types of bridges. And so there's going to be a French bridge, and then there's going to be a Belgian style bridge, which is what the style I'm going to be going with on my wood cello. Now, the reasons behind this I'm not going to really explain here. I'm going to make another video that's all about the science behind tone and why something sounds the way it does. Alright, so the first thing you're going to need is some kind of measuring device. I'm using one of these digital calipers that can read in millimeters, inches, and fractions. You can pick up these, like a cheaper one for like 20 bucks on Amazon or something. You don't really need to break the bank when it comes to a digital caliper, and honestly, unless you're doing something that requires a lot of precision and accuracy, then that's when you're going to really start getting those expensive calipers. But for what we're doing here, the precision of this and the precision of like my 3D printer are this is worlds ahead of that, so that's something you're not going to have to really worry about. So now with the cello here, it might be a little daunting looking at all the curves and all these things that, you know, there could be a lot of measurements to take, but honestly we're going to break it down into just a few key points, and also a trick that I learned from one of my cello teachers in high school. So you're going to take either a number 2 pencil or one of these pens, and that thickness that you have here is actually almost perfect for projecting the angle of your fingerboard onto where the bridge should be. Now there's other choices that we're going to talk about in the other video about tone signs and where this should be in relationship to your sound post. In the case where you might not have a bridge right now and you would have to make a new one, you can still follow these steps and make one from scratch. But it's really good if you already have a feel of where you want your bridge to be. So what's going to happen here is you're going to basically take your pen and you're going to find a height. And since I'm not too worried about getting pen on this, I can either just sand it off, or if you have a bridge that you're pretty worried about, you can use some pencil. But honestly, the current setup on this is horrible. So you're gonna take your pen and you're gonna mark the ends here. One here and one here.
Yeah, I'm just gonna interrupt here for a second. When taking this measurement and marking, you're gonna end up adding half of the thickness of the pen or pencil that you're using to the vertical measurements that we take in just a minute. So the thickness of the pen was like about 8 millimeters, and you're going to add half of that, which is 4. The reason is that the marking point is obviously in the center line of the pen or pencil, but the thickness is the measurement that you want. So you're just going to have to add half of your writing utensil to the measurements.
And with the pencil, it's a lot easier, and then using the pen, hopefully you have one that works. Okay, so then once you have those marks, you're gonna take your depth part of the caliper, the depth gauge, make sure you're zeroed out, and you're gonna measure right to the face of the cello to the mark you just made. It's gonna be negative 63 millimeters. So we're gonna mark that down here, 63 millimeters. And we're going to say this is on the A side, so keep that in mind because this profile is different. On some cellos it's the same, but usually you're going to have a cutout on your C string. So keeping that in mind, you're going to do the same thing for the C string. like 62 or 61 millimeters. And that's on the C side. So now you can draw like a little, you're going to take your piece of paper and you're going to try to fit it up under here and get it as flat to that surface of your bridge as possible. And just trace the profile of your bridge. And then what you're going to do is you're going to mark a little line here around the edge so you can see where that ends. This is all going to be really important for modeling later because we're going to use this profile indefinitely. So one thing you might notice here is that there's like a really sharp edge where my C string side is. So be sure to mark that so you don't forget. And what that is there for is that the C string and your lower strings are going to vibrate more and have a higher move, like the displacement that it moves for those lower frequencies is much greater. And it can be a situation where if you're playing louder, you might actually have the string collide with the fingerboard. Now, with my current setup, that is not a problem. It's way too high, but when we get this down to where it needs to be, that could definitely be a real problem. So, because the bridge needs to support it, you're gonna pretty much trace the bridge and connect the lines, but there is some tools that we're gonna be using in the 3D modeling software that can help guide that. But just keep the line that you drew and then kind of project it a little bit farther. So with the measurements we have here, take your 63 on the A side and 61 on the C side.
So again, I just want to reiterate, you're going to take that half thickness that we got earlier, the 4 millimeters, and add that to the lengths that I just said here. This ended up kind of carrying through the rest of the video, so just keep that in mind when watching, and it ends up biting me in the butt when I actually print it out. So yeah, we'll see where this goes.
And mark those down. So now we have our leg heights. Now the next thing is something I almost forgot. On some wood cellos, they have a very pronounced curve. On my steel cello, I did still have a curve, but it wasn't as much. So to attack this issue, you're going to basically create a tangent line with your pencil. And you're going to hold it right here in the center. And you're going to notice you have a displacement here. So what you're going to do is take your depth gauge, and you'll see how this is going to all pan out in a minute. So let's call that 10 millimeters. It's the height that you measured from the tangent.
So yet again, I forgot the thickness of the pen when talking about this. So we got 10 millimeters from the face of the cello to the top of the pen, and then you're going to subtract the thickness of the pen, which was 8 millimeters. So overall, there was a 2 millimeter height that we're going to be writing down.
And it will generally be the same for both sides. We're taking a arc line, and we're going to be using the CAD software to complete it. You're going to take the width from the measurement points. It doesn't have to be perfect, but the wider you go, the more shallow the angle will be with the height that we measured. So it's going to be safe to say that you want to definitely have a shallower angle than a more pronounced angle, because the force of the strings pushing down on this PLA plastic that we're going to be using is going to let it form itself. So we have a width of 74 millimeters. Okay, so now what's going to happen is we're going to have the A side height, we're going to have the C side height, we have the profile, and then we can connect the line here at the bottom, and we have a height of 10 millimeters. And we have a width of 74. So we have this profile, the A leg and the C leg, and then finally we have the little the shallow we have the shallow curve for the face of the cello. So these are all the measurements you need to take, And now we're ready to go right into the CAD software. All right, so the last thing we're gonna do here is we're actually gonna try to get a really good shot of the profiles we drew straight on, and we're gonna take a picture of that. Make sure you get really good shots of what you got going on here, because and you don't want to have any like weird angles or things that skew the actual profile.
All right, so we're going to be using SketchUp Make. It's completely free to use. You can also try to do this with Fusion 360. So you can see here, yeah, Autodesk Fusion 360 or any one of those programs, but honestly, this is one that has a lot of built-in features that make doing the bridge really easy, and I feel like anyone can approach Google SketchUp with no 3D modeling knowledge. So as long as you follow this tutorial, you'll also get a slight tutorial in Google SketchUp. Now, I use Inventor and many other things, but for this and 3D printing, Google SketchUp is really good because it focuses on mesh 3D editing as opposed to objects that have sketches and are more like a step file as opposed to a 3D mesh or a surface. So SketchUp is really good for making these surfaces and meshes that you can use with 3D printing and other software. So the first thing you want to do is we're going to go back to Window and we're going to go to Model Info. And we're going to see how I didn't really switch everything over. So we're going to put this in millimeters. You don't really need this many decimal points, so you can just stick with something like that. And then you can turn off angle snapping. I would keep it on, but do like a one angle snap, because when you're working with smaller objects, the angle snapping can be nice, but a little finicky when you start getting into smaller and smaller units. So this is the kind of things I would advise. So honestly, you can just delete that, and then you're gonna look at from above. Oh, also your toolbar. Here's the other thing that you're gonna have to turn on. Have these all checked off how I have. So the default should be like how it looks here, but I've definitely customized mine. You can move these around, and definitely there's a way to get your advanced. Alright, so now that you have this all here, we want to be in parallel projection, not perspective, and then that'll allow us to model this very accurately. So first you're just going to throw together something with the dimensions that are bigger than the overall dimensions that we had. So I think we had 74 and the largest height is 63. So let's just make it 70, or let's make it 80 by 80. And I'm actually typing on the number pad you can see in the bottom right. Sometimes you have to type in the lengths, but it can be a little finicky sometimes. There you go. Alright, so now that you have that, we're going to actually make a texture. What I would say that you should do is when you take that picture that you took, connect your phone or whatever your camera, and then use some kind of software to crop your profile, and then make sure you definitely have the edges there, and then save that picture somewhere. So then once you have that picture saved, you're going to go into this paint bucket, and we're going to create a new material, and the material will actually be the image. So bridge profile. Okay, so now that you have that, you're going to paint what we just had here as the profile. Alright, now the last thing you're going to do is you're going to take a line, and we're going to make the very first line, the width of the fingerboard, or the width that you want to use to scale the profile that you drew. So we're going to use the 62 millimeters from before, and then the snapping is already there, the axis snapping. See how it's red? And then that's going to be the other axis, and then it won't snap to the blue axis because in parallel projection it's going towards infinity. So let's go to that 62, type it in, and now we have a line. Now this one looks like it's going to be really easy, but it's usually not, and it does some weird things. So let's say this is like way too small, and you're going to go into the edit of this, and you can drop this down. If this is like really tiny and it's not within a good range, you can increase this. This locks the aspect ratio, and generally this shouldn't need to be changed, but if you feel like you had some distortion in the picture, then feel free to change this ratio by clicking that and breaking the aspect ratio link. So then you can change this number and it'll scale it up and down, and it'll usually tile it, but we're going to be changing this anyway. So once you have this painted and that's all good to go, you can get out of this little window and you can right click on the face. You're going to go to texture, and we're going to go to position. Now don't touch these guys here, only use this arrow and the green rotation sign. So we're going to first get that in a good location where we're going to try to line up that and see, alright, it's actually in a pretty good general size, but it looks like it needs to be a little bit bigger. And then that angle snapping is going to step in now. With that lesser angle snapping, you can rotate it freely and then just click and drag and repeat the process until you've connected those 2 points. And it doesn't have to be absolutely perfect, but what you got here is pretty good. Now, see how I wrote down the A and the C side? It sometimes mirrors it, so definitely have it written on the profile that you drew. So this is actually going to be mirrored when we're done. So what I would do first is take the pencil tool and just kind of sketch it out. On SketchUp, yes, pun intended. And then we're going to be increasing the resolution of this curve using these points. So then once you have something that's pretty nice, you're going to grab this tool. Actually, you're going to take this one right here, the 3-point arc, and you're going to basically start connecting lines. Now when it's this small, see in the bottom left it says use Control plus or Control minus, you're going to definitely have to subtract some vertices because of how small this is. So see how it says 9 sides per arc? You're going to have to lower that to like 5 or something because it's too much detail for the program to handle, and honestly you don't want to mess with that. And then typically as you do this, you're going to be making this curve smoother and smoother. Now the erase key, I've already memorized the thing for it, but it's like it's E, and then you have some of these tools that you just remember the actual shortcut. But overall, I'll try to use the buttons. But if you see me doing something, I'm sure I'm going to do it again, and I'll try to use the button the most. It's just it's a force of habit. So sometimes when you use this tool, see this blue line? It's actually going to draw a tangent line and make that tangent with the same profile, and then you can extend it all the way out. And if it looks like it's following the profile pretty good, then by all means extend it all the way. So what this does is it makes a really clean curve. And when you 3D print this, you're not going to have like jaggedy edges like you would here. So that's what we're trying to achieve overall, is like a very nice profile from the by drawing it out like this. And it'll snap to a few different ones, but honestly you're just going to be doing this by eye, and you can get the feel of this, but it took me a bit of time to get the feel of how to, you know, position these before I commit to the curve. And definitely try to overshoot. You don't want to make it too small. It's always safer to make it a little bit bigger because adjustments can be made later on, though you don't want to count on it. And then there you go. So now we have our profile. So the next thing we're going to do is we're going to take, we can actually now delete our profile that we had here, but keep your measurements somewhere safe so you can reference this. So the first thing is, because if this is mirrored, which it was, we're going to actually flip along this on the red axis. So how you do that is you select everything with the, if you select something with from top left to bottom right, it usually selects like one line. So see that? But if I use from bottom right to top to left, it'll select everything touching that box. So I typically use the bottom right to left to make sure I'm not missing any vertices or lines. And once you do that, right click on here and we're going to flip along the red direction. And there you go, now we've mirrored it. And also definitely keep this line going across, because we're going to use that as our midpoint. And it usually snaps to midpoint with this blue dot. Now here we're just going to make a general mirror line, but don't worry about the specifics of this. And we're going to do one side at a time, and then extend this line up as well, making sure it goes a little past. I hit erase, but try to look for the buttons that I highlight here, because I'm used to doing the shortcuts. I'm sorry. Now we can be a little bit artistic, but definitely let's get the leg lengths right. So on the C side, we had the C side was 61 millimeters. The A side was 63 millimeters. Now, if you have a case where these are definitely different, what you're going to do is we're going to actually take the line down here that we had. The longest line, you're going to draw a red axis line going across. Then what you're going to do is you're going to delete that line. Make a new one. Don't click on this, but highlight it. Then you're going to see that projection line. You're going to hit that and make sure it's on the edge. And then you're going to click on the line from here. You're going to go up and then do that shorter 61 millimeters. Then what we're going to do is we're going to rotate the profile so that it fits the bridge. So let's eliminate our extra lines here. And then you should have a curve. You can hold control to add to the selection, and then we're going to actually rotate this by selecting the rotating point, connecting it to this dot here, and then putting it in line with this. Now it's not always going to connect, and if it doesn't, you can zoom in pretty good there. Actually, you can hopefully, if you can't trim that line, then what I would advise is deleting it, taking this, using that little blue projection line, and just having it connect with the projection line. And then if it closes, if you don't have any open spaces, it should automatically create the face. So now that we have the midpoint down here, you're good to go. And now we're going to have the proper slope for this and the lengths of the legs. Now, if you remember down here, we had the legs with the curve. So this will be another kind of nifty trick, is that you're going to keep this bottom line, and we're going to take the bottom distance, which was 74, and we're going to split that in half. So half of that is 37. Yeah, so 37 millimeters. From the center out, it goes 37 millimeters. Okay, and then you're going to go up, what was it, 10 millimeters in the center. So now you're going to have a line here, a point, and a point here. And then you're going to take this, and what it will do is it'll hopefully see that you're trying to make a tangent line. Depends on where you start. Alright, so this is going to determine, as you extend this out, if it's going to be tangent to that line. And usually, like I was saying, you want to make it a little bit steeper. We're going to take, now we're going to have this profile here. We're going to select the face. You're going to hit M. It's going to select the move tool. Select this point here in the center, click it, and then hit Control. Don't drag yet. And then you should see that little plus when you hit Control, and then now you've created a new face. You're going to reverse this. Flip along the red direction, and then move it back to the point here. So now we have a very it looks a little bit more pronounced on screen, but trust me, when you print this out, the scaling definitely goes back to normal. That's just a byproduct of the parallel projection, unfortunately. And also your whatever screen you're using. So now you should have a pretty nice thing to work on. So if you want to make something abstract, you can definitely do whatever you want, and watch my tone science videos so you can get an idea of what kind of consequences of the shapes you make what kind of sound. Now, because I want a Belgian style bridge, I'm going to make a very light top to this with extended legs. So now from here on, I'm just going to kind of go on through this. It's going to be a more artistic side, and we'll see where this goes. Alright, so what I'm doing here is I'm scaling and holding control. As you can see, the lines here stay, but it always wants to complete the curve as best as possible. So it usually does all that automatically for you. I actually almost, I noticed something wasn't quite right about this. Notice how steep this was. I said 10 millimeters for that the bulge here for that slope, and actually it needs to be that 10 minus the thickness of the pen. So how I fixed that was by doing this tool between the two endpoints, and then we're going to do the 2 millimeters because it's 10 minus the 8 thickness. Now once you have that, we're going to do the projection line. And once you have that, we're going to delete the old curves and the now unneeded faces. So that looks a lot better, and we have that nice slope that goes with the face. Okay, so now we're gonna, if you want to look up the dimensions somewhere else, I already have them here. So the top is going to be 3 millimeter thickness, and then we're going to actually draw another line here at the very end. Bring it up 11 millimeters, and then we'll create a line that is in plane parallel to the bridge, and then we're going to make sure we're in parallel projection. You gotta make sure you only select the face. Make sure you're on the side there, in plane. There you go. And then you're going to make sure that it intersects with, or at least as high as that point. And that'll work. Now you can delete it. It is no longer needed. And then what you'll do is, if you see these lines get created, take the one that's closest to the legs, which is right here, and project a line through the whole thing, through the legs. And then what you'll do is, let's get the camera back into perspective. That's why it's doing that. I'm going to select this curve, hold control, select that curve, and we're going to move that towards, by using the arrow keys, we've locked the axis, and then we're going to have it aligned with the back face there. So why we did the line is this creates a complex face if you were to move it normally, and so by doing this it keeps these coplanar and prevents any problems occurring when deforming that face. And so it's just a little trick to keep you from having to rework stuff. See how I had to deform this and make new triangular faces? You want to prevent that as much as possible, because if it had to do it from here, it would make some really crazy projections off of like this face all the way to the legs. So you want to try to mitigate that as much as possible. Now this is fine how it is, but if you want to go one step farther, we're going to make a nice little curve to this by creating a box that's slightly bigger, and then you're going to project a line off of this corner. We're going to hit the right arrow, the red axis there, to lock axis, and you're going to take it to here, and then again red axis, Then if from here you can do some lines that intersect with that face over here. And then this is where we're going to start getting a little bit fancy. We're going to make one compound curve. Make sure that camera needs to be in perspective now. Sometimes you have to switch between cameras so it can refocus. That's going to be your flat line. Use this curve shape. Alright, then once you get to the legs, do like a really sharp tangent. There you go. Look at that. And then what you'll do is you'll connect the 2 points here. And then this is where the magic happens. Delete this extra line. You're going to take that face, hit the push-pull tool, which is right here, run it all the way through here, and then what you'll do is you're going to intersect faces with model. And then upon deleting this, it's going to make some weird geometry when you do this. It did not work. Alright, if it doesn't work the first time, you might have to make this shape a little bit bigger so that it overlaps the model, because if it doesn't properly overlap, it will not do its thing. You just need that profile. So then again, do the push-pull and select everything. Just get everything up in there. Intersect faces with model. Now, upon deleting all this, you should remember that this is a very powerful deleting tool. One of my favorites is that bottom right to top left. And then if we delete all this, you can see we've just created some very pleasant curves without having to completely okay, sometimes if these aren't connected, that'll happen. Oh man. There you go. The last thing you want to do is delete all those very complex curves that we made. And sometimes it requires drawing lines through it to create those coplanar instances. See, there you go. These didn't intersect correctly. Now sometimes this happens and it's just, come on. Actually, it looks like it was just an illusion. If it's that weird color, you can flip the normal or reverse faces. That's all that means, is that the normals are in the wrong direction. Look out for any gaps. Fill them with lines. Gosh, you know, I hate this crap. Come on. And that's what you get sometimes for trying to be a little fancy. But now we can actually export this. Alright, so you're going to have to get one of these plugins. It does not come preset up. So how we're going to do that is, I think it's Extension Warehouse. And you're going to find these, let's get to the STL actually. Extension Manager, I'm sorry. You're going to install an extension. You're going to find this in STL import and export. If you can go and find this, definitely a really nice exporter for 3D printing. It does a perfect job. I've had no problems with it. Use the Export STL tool. Alright, if you've gotten this part and you do have a 3D printer, I'm going to assume that you are familiar with your slicer, and I want you to focus on the key things of having your wall thickness at like a really good level, like about 3 to 4 layers, or even 5 depending on what you think of my tone science video and how that'll affect it, and then also how the infill lines up. You'll see that shown here for a brief moment, but this is just assuming that you're familiar with how your printer settings are. And then if you already use the model once with the settings, then we can go back and fix it here. And then remember everything I explained before. We'll just have to double check the infill, and it should. Yeah, we might have to move this a little bit. Alright, I think that's all good. Now this is ready to print. Alright, so here's the setup of the 3D printer. I almost forgot to give you the bed temperature and the hot end temperature. It's going to be 240 for this PLA I'm using, and then about 45 to 50 for your bed temps, depending on, you definitely want to get a feel of your printer before you proceed. But these are settings that have worked for me.
Alright, so the print is done, and actually the fitment, it looks really good for the feet. I did have to clean up the bottom with like a razor blade, and you can definitely see how much shorter this is going to be compared to my old Action, which is, I mean, it's really high. So this should definitely play a lot better, but also we're going to be seeing how this will affect the tone of it, because as you can see, the legs are much closer together, and where the end pin is might affect the sound. So this is just like a prototype, and we'll definitely see how it sounds. Alright, so now fitting the strings, we're gonna get something that is a little sharp, and we're gonna actually take the sharp edge, put it right next to the string, find where this centers, and then just score a little mark into there. Alright, the last thing you'll need is one of these 3D printing pens. And again, not too expensive, but you'll definitely need to, I got one of these ones that was metal as opposed to all plastic, and this one has held up pretty good. I've used it for repairs of other plastic things, like as like a little plastic welder. And what we're going to use is, we're going to use that little tip to pretty much cut out the part where the string comes through. And then as you're looking at it, if you feel like you're off a little bit, just try to keep these distances as equal as possible. All right, that's looking pretty good. All right, so here now we're gonna try to put it on. When taking off your strings, be mindful that the change in tension and how much this will move will not knock it over potentially. And then, you know, just watch everything while you're doing it. Don't just go for it. All right, and then for this, we're gonna just do it before and after. So this is with the normal bridge.
Hey, so my final thoughts on this is that I definitely achieved the difference in tone that I wanted. I was going for a brighter and more pronounced kind of tone. However, this was a prototype and I did have some problems like the 4 millimeter discrepancy for the height, as well as maybe being a little bit too thin after I made those fancy curves in the face of the bridge. So with all of that, I'm definitely going to be working a bit more on some other bridges, and then look forward to my tone science video. And I hope you enjoyed it. Like and subscribe.